Good morning, afternoon, or evening, cats and dogs. Today's video will focus on the lessons 8.2 and 8.3 guided notes on writing and solving two-step equations. In this video, we'll cover problems 1 through 11 in the guided notes, including some independent practice. Don't forget to have the notes in front of you. Make sure you're copying down the guided notes. You can feel free to try some of the questions on your own, and there will be some independent practice built in as well. But you definitely want to make sure you're writing down these example problems and working through them during the video. So let's begin with our example problems. We've already worked with inverse operations with one-step equations. We're now going to talk about two-step equations. So these are going to take two inverse operations or two steps to find our solution. So let's begin with question number 1, which is already done for us. The equation is 5t plus 2 equals 7. So what we want to do is identify what's happening to the variable. We kind of got away from this with our one-step equations after we saw a lot of examples and a lot of practice problems, but we're going to do it for the two-step equations, at least for now. You might be able to get away from doing that as well, either today, tomorrow, or later on this week, or within a few days of seeing some problems with two-step equations. But I want to make sure that we're listing this for this first set of questions that are two-step equations to solve. So in number 1, our equation 5t plus 2 equals 7, the first thing that's happening to the variable is that we're multiplying it by 5. We always want to find our variable and identify what's happening to it. And we're multiplying it by 5. After we multiply our variable t by 5, we're adding by 2. So our inverses are as follows. The inverse of multiplying by 5 is to divide by 5. The inverse of adding by 2, remember we have two possible inverses here, is either to add by -2, which I have written, or you can subtract by 2. Both inverses will work. Remember, for addition and subtraction, there's two possible inverses. Now, when we go to solve, though, we're actually going to work in reverse order, and you'll want to fill in those blanks in your guided notes. So we work from the bottom to the top here. So we undo what was done last to the variable. So the last thing that I did to the variable t was I added 2. That's the first thing that I'm going to undo. So I'm actually going to begin by adding -2. Let me go ahead and highlight that for us. I'm going to begin by adding -2 to both sides. So you can see that I do that on the left and on the right. You also have the option of subtracting by 2. So 2 plus -2 cancels out, but you're still left with 5t. And then on the right-hand side, we have 7 plus -2, which is 5. Notice how once we do our first step, then all we have is a one-step equation left to solve. So again, we're working in reverse order. Now what we're going to do is divide both sides by 5, since that's the inverse of multiplying by 5. We'll show that here. 5 divided by 5 gets you 1t. 5 divided by 5 gets you 1. So your final solution is t equals 1. You can check your solution here. If you grab your calculator, you can do 5 times 1 plus 2, hit equals. You want your calculator to give you 7, and it will. So again, the main things here is list what's happening to the variable in the order in which they're occurring. List your inverse operations and work in reverse order. Mr. Underkoffler likes to call this SADMAP, which is the opposite of PEMDAS. So instead of doing multiplication and division first, and then addition and subtraction, we actually work in reverse order. So addition and subtraction come first, then multiplication and division. That can sometimes fall apart depending on which kind of equations that we have. We will see some equations where you might actually multiply or divide first and then go with adding and subtracting. So I don't want to stress that too much, but it is a way that you would typically do these problems. Add or subtract first, then multiply or divide. So let's take a look at a second example, because practice with solving equations really does help us get better with this. So our second equation is 6u minus 8 equals 28. The first thing that's happening to the variable u is we're multiplying by 6. Then you're subtracting by 8. So our inverses, the inverse of multiply by 6 is to divide by 6. And if you want to write that out using the multiplication and division symbols, that's fine too. It's just a little easier for me to type it. The inverse of subtracting by 8 is to add by 8. So remember that we're going to work in reverse order. So we're actually going to start by adding by 8 on both sides. Let me go ahead and highlight that in green for us. So let's add 8 on both sides of our equation. Plus 8 on the left, plus 8 on the right. And again, I'll highlight that in green. -8 plus 8 cancels out. We want to do 28 plus 8, which is going to get us 36. So we have 6u equals 36. Now we're going to divide both sides by 6. Let's go ahead and do that. 6 divided by 6 gets you 1u, and then 36 divided by 6 gives us a final solution of 6. Keep in mind, a lot of these I'm going to make work out nicely where you get whole numbers or integers as your solution, but it's also possible to get decimals as well. And we'll talk about some of those types of questions. But remember, you can check your solution, do 6 times 6 minus 8, hit equals. You want your calculator to give you 28 to assure your solution is correct. All right, let's move on to number 3. So this one's kind of backwards the way it's written. 21 equals 42 plus 7k. The first thing that's happening to the variable is that we are multiplying by 7. So the variable is k, we're multiplying by 7. The inverse of that is to divide by 7, and we'll do that in a few moments. After we multiply by 7, we're adding by 42, and the inverse of that is to subtract by 42. So remember that we're going to work in reverse order here, meaning that we're going to subtract by 42 first. Try to make that as straight. That's not a straight line, but we'll go with it. So we're going to subtract by 42 on both sides to start. Notice how I line it right up with the other 42, just makes things a little neater and a little nicer. What we want to do is 21 minus 42. You may use your calculators or do it mentally, but I would definitely double check everything. We're going to get negative 21 equals 7k. Just bring that 7k down. Now what we need to do is divide both sides by 7. So we'll do that as our next step. Divide both sides by 7. Negative 21 divided by 7 is negative 3. So our final solution is negative 3 equals k, or k equals negative 3. All right, let's take a look at our next one. Our first one that involves division. And again, you might feel comfortable trying some of these on your own. That's fine. Just double check your solutions as you're working through them with this video. So in number 18, the first thing that we're, or number 4, sorry, the first thing that we're doing to g is we're dividing by 3. The inverse of that is to multiply by 3. After we divide g by 3, we are then adding by 6. So the inverse of that is to subtract by 6. We want to work from the bottom to the top, working in reverse order. So the first thing that I want to do is subtract by 6 on both sides. So we show that once on the left and on the right. On the left, 18 minus 6 is going to get us 12. We're still left with g over g divided by 3 on the right-hand side. So the next thing that we need to do is use the inverse operation of multiply by 3. That's the inverse of dividing by 3. Show that once on the left and on the right. These guys will cancel out on the right-hand side, because remember, if we divide by 3, then multiply by 3, we end up getting 1g, or g over 1. We need to do 12 times 3 to get our solution, which of course is 36. All right, let's flip the page and let's go ahead and take a look at question number 5. So number 5, also kind of in reverse order with the variable coming second. We've got negative 7 plus 2x equals 9. The first thing we're doing to the variable x is multiplying by 2. The inverse of that is to divide by 2. After we multiply by 2, we're adding by negative 7. So the inverse of that is either to subtract by negative 7 or add by 7. Let's work in reverse order. So the first thing that we're going to undo is that adding by negative 7. So we're going to add by 7 on both sides. Let's go ahead and do that. Add 7 on the left and on the right. We're going to be left with 2x equals 9 plus 7, which of course is 16. The inverse of multiplying by 2 is to divide by 2, so we're going to divide by 2 on both sides. Pretty easy here with not a lot of negatives in this problem. 2 divided by 2 is 1x. 16 divided by 2 is a solution of 8. All right, we've got a couple more that involve some fractions here, number 6 and 7. Let's take a look at these. I don't have as much space to show the what's happening to the variable and the inverse, but I'm still going to write it for these. You might be getting to the point already where you don't have to write or show that, but I think it's not a bad idea to still continue to do that, at least for today. So in number 6, the first thing that's happening to the variable is we're dividing by 4. The inverse of that is to multiply by 4. And after that, we're adding by 13, and the inverse of that is to subtract by 13. Let's work in reverse order here. So the first thing that we're going to do is subtract by 13 on both sides. So we'll highlight that in green, and we'll subtract 13 on both sides. 13 minus 13 cancels out, leaves you with a over 4. Be careful though, negative 3 minus 13 is not 10 or negative 10, it is negative 16. So I want you to be very careful there. We are now going to do the inverse of dividing by 4, which is to multiply by 4. So let's multiply by 4 on both sides. We're going to do negative 16 times 4, and that's going to get us a solution of negative 64. Again, it's not a bad idea to double check your solution. So if you're going to do this in your calculator, 13 plus negative 64 divided by 4. I would not put it in as a fraction, even though it's written that way. It's just easier to use division to check your solution. All right, let's take a look at number 7. So the first thing that's happening to the variable c is we're dividing by 2. The inverse of that is to multiply by 2. After that, we're adding by negative 3, and the inverse of that is to add by 3. We certainly want to work in reverse order here. So the first thing we're going to do to find our solution is add by 3 on both sides. So let's go ahead and add 3. Let me move this out of the way. Add 3 on the left and on the right. It's going to cancel out on the left to leave you with c over 2. 12 plus 3, of course, is 15. We now want to multiply both sides by 2. So let's go ahead and do that. Whoop, almost gave you the answer there. We're going to be left with c on the left-hand side. And of course, 15 times 2 is 30 for our solution. All right, let's give you a chance to try a couple of these on your own. You can do these any place where you have some space, maybe on the back of these guided notes. You have a little bit of space there, or just any place where you might have some room to put some practice on these things. All right, maybe a sheet of paper. So we've got two questions. Number 1, 6 plus 5x equals negative 29. Number 2, let me slide this up a little bit, is negative 6 equals x over 15 minus 9. Go ahead and pause the video. Give these two questions a try. All right, so hopefully you paused the video and gave both 1 and 2 a try. Let's take a look at number 1 first. The last thing we're doing to x is adding by 6. So let's undo that first. We're going to subtract by 6. We're going to be left with 5x equals negative 29 minus 6 is negative 35. So just double check that. If you accidentally had like 23 or negative 23, you could have missed a negative when you were calculating negative 29 minus 6. Now we need to undo multiplying by 5. So divide both sides by 5 to get a solution of x equals negative 7. All right, number 2. So the last thing that we're doing to the variable x is subtracting by 9. Let's undo that first. Add 9 to both sides. Negative 6 plus 9 is 3, so we have 3 equals x over 15. Multiply both sides by 15 to get our final solution of 45. Hopefully you got at least one of those correct. Keep in mind this is the first time we're seeing this. We'll try to make sure we reinforce these topics as many times as possible. You'll get some additional practice on this as well, both in class and outside of class things to practice. But you should at least feel fairly good about these. Keep in mind with 2 steps, there's a lot more places where you could go wrong. So just be really careful with your work, because one little mistake at the beginning could throw off the rest of your solution. All right, so numbers 8 and 9 are very similar. In fact, number 8 is basically the same as question number 9, just with different numbers. Number 8 is done for us. The question is 35 minus x equals 21. So I'm going to say something that's really important here. In all of the questions we've seen thus far, the variable has come before subtraction. So if we go back to some of our other problems, actually this one here, x came before the subtraction. We go back to, I know we have others. We go back to question number 2, the variable came before subtraction, and we didn't see that in any of the other ones. But in all the problems we've seen thus far, the variable came before subtraction. This is the first problem that we're seeing the variable come after subtraction. So I'm going to ask you many times that anytime your variable comes after subtraction, that you rewrite it as an addition problem, that you add the opposite. So I'm actually going to rewrite 35 minus x equals 21 as 35. I'm going to highlight this in purple. 35 plus negative 1x equals 21. I'm also adding a coefficient of negative 1 in front of the x. I'm not really adding it. It's already there. It's just not normally shown. So I'm going to rewrite it as 35 plus negative 1x equals 21. So the mistake I see students do a lot with number 8 is they think they can just add 35 to both sides, and they end up getting a solution of 56. And that's not correct, you'll notice from the rest of the work. What we need to recognize is there's 2 things happening to the variable. We're multiplying by negative 1, and we're adding by 35. The inverse of multiplying by negative 1 is to divide by negative 1, and the inverse of adding by 35 is either to subtract by 35 or add a negative 35. So we work in reverse order, which means we're going to add by negative 35 first. That's going to get rid of this guy. If you add a positive 35, these will not cancel out, which is why we add a negative 35 or subtract 35. So that leaves you with negative 1x equals negative 14. Now what we're going to do is divide both sides by negative 1. Negative 14 divided by negative 1 is positive 14. So let's take a look at question number 9. I would start by rewriting this thing as 19 equals 9 plus negative 1y. So the first thing that's happening to the variable is that, let me just move this box out of the way, we're multiplying by negative 1, then we're adding by 9. So the inverse of multiplying by negative 1 is to divide by negative 1. The inverse of adding by 9 is to subtract by 9. Remember, we want to work in reverse order here. So the first thing we want to do to find our solution is subtract by 9 on both sides. Let's go ahead and do that. If I try to add by 9, these are not going to cancel out. A 9 minus 9 becomes 0, and you're left with negative 1y equals 19 minus 9, which is 10. Now what we want to do is divide both sides by negative 1. So we'll go ahead and divide both sides by negative 1. 10 divided by negative 1 is going to get us negative 10 for our solution. These are really beneficial to check, and since you have a calculator, it's really simple. Just plug in 9 minus negative 10, hit equals. If it doesn't give you 19, you know your solution is wrong, but it will. All right, I have one for you to try independently. So just like before, pause the video, give this question a try, and then we'll take a look at the solution. All right, hopefully you've taken a few moments to try this problem. And hopefully you remember that since the variable comes after subtraction, we are going to add the opposite and rewrite it as 8 plus negative 1t equals negative 10. Now, we are adding 8, so the inverse of that is to subtract 8 from both sides. It's going to cancel out on the left. You're going to be left with negative 1t equals negative 10 minus 8, which is negative 18. Divide both sides by negative 1, you will get t equals positive 18. If you remember, we actually saw problems kind of similar to this without the number in front here. So we had like a negative t equals negative 10, and you had to find a solution for that. We added a 1 in front of your variable. So we did see problems like this, but now we're doing two-step equations. So we're kicking it up a notch. All right, so we have 2 more questions to see and then 1 for you to try independently. Number 10 is also done for you. Number 11 is very similar. So in number 10, the variable comes after subtraction again. This time there is a number besides 1 in front of the variable. It's 2, in fact, a negative 2 once we add the opposite. So I do highly suggest you start off, and I'm going to highlight this in purple, by rewriting this as 14 plus negative 2y equals negative 18. Why? Because the variable comes after subtraction. You may be able to get away with not adding the opposite at some point, but we're not quite there yet. So please do it anytime the variable comes after subtraction. You can do it on any of the other problems as well, but especially when it comes after subtraction. So what's happening to the variable? Let me go ahead and pull this down. We are multiplying by negative 2 and then adding by 14. The inverse of multiplying by negative 2 is to divide by negative 2, and the inverse of adding by 14 is to subtract by 14. So when we work in reverse order, that means we're going to subtract by 14 first on both sides. We get negative 2y equals negative 32. Now divide both sides by negative 2 to get y equals 16. All right, in number 11, I'm going to strongly suggest you rewrite this as 12 plus negative 8r equals 60. What's happening to the variable is we are multiplying by negative 8 and adding by 12. The inverse of multiplying by negative 8 is to divide by negative 8. The inverse of adding by 12 is to subtract by 12. So we want to work in reverse order. That means that we are going to subtract by 12 on both sides first. Let's go ahead and do that. So we'll subtract by 12 on the left and on the right. We end up getting negative 8r equals 48. Then we want to divide both sides by negative 8. So we'll go ahead and do that. On the left-hand side, we're going to be left with 1r, or just r. 48 divided by negative 8 is negative 6. All right, so the last thing in this video is an independent practice problem. Pause the video. Give this one a try. All right, so I really hope, again, you remember that since the variable comes after subtraction, that you started by adding the opposite. We've got a plus 9 here. Let's undo that by subtracting 9 from both sides. That's going to leave us with negative 5j equals negative 15, negative 6 minus 9. Then the inverse of multiplying by -5 is to divide by -5. So divide by -5 on both sides to get j equals +3 for your solution.
Continuing with numbers 12 through 13, we have, again, some more challenging questions that involve solving two-step equations. Number 12 is a question that's already done for you. And you can notice that we began by rewriting subtraction as addition. That's going to help us anytime we simplify an expression or combine like terms. Where we had this -16, we wrote that as plus a -16. I know a lot of you can probably get away by skipping this third line here where we rewrite the like terms side by side. I'm still going to show that at this point. So we put our 8x and our 8x side by side, and then our plus -16 will go here at the end. At this point, we can combine our like terms. 8x plus 8x is going to get us 16x. And again, some of you may not need to show every single one of these steps, but I do suggest anytime you're simplifying expressions or moving terms around to rewrite subtraction as addition. So we end up with 16x plus -16 equals 16. This is now a two-step equation. The inverse of adding a -16 is to add a +16. So we showed plus 16 on both sides. That leaves us with 16x on the left, and on the right, 16 plus 16 is 32. Final step, the inverse of multiplying by 16 is to divide by 16, which we showed. 32 divided by 16 gets us 2. Now we can check our solutions for these as well by replacing x in the original equation with 2. So you would have to do 8 times 2 minus 16 plus 8 times 2, hit equals. Your calculator should give you 16. If it doesn't, then it means your solution is not correct. In this case, 2 is the correct solution, so you'll get 16. Let's take a look at number 13. The first thing I did was I simplified this equation. 12a minus 14a, you can write as 12a plus -14a, but that's going to be -2a, and then it actually becomes a one-step equation. The inverse of multiplying by -2 is to divide by -2. Keep in mind, sometimes I'll have students add 2 to both sides, but that would only be if this were a plus -2 or -2 plus a. The operation between a and -2 is multiplication, so we divide to solve. 8 divided by -2 gets us our solution of a equals -4. Let's move ahead to question number 14. So kind of like question number 12, we do want to simplify first. So the first thing I did was I rewrote subtract 2y or minus 2y as plus a -2y. Again, that's because I'm going to be moving some terms around to simplify. The next step is to put my like terms side by side. So I have -1y plus -2y. I also added that coefficient of -1 in front of our y, or the 1 there. -1y plus 2y plus 42. Now, at this point, we need to combine our like terms. -1y plus -2y is going to leave us with -3y. It gets us down to a two-step equation, and that's our goal because we know how to solve those. Excuse me. The inverse of adding by 42 is to subtract 42. 6 minus 42 is going to get us -36 equals, I apologize, that's going to keep sliding down, equals -3y. Divide both sides by -3, and -36 divided by -3 is going to get us +12. Move this up so you can copy that down. All right, let's move ahead to question number 14. Number 15. So we've got b plus 8 minus 3b, which I'm going to rewrite as plus a -3b. I'm going to put my like terms side by side. So that's going to be my 1b and my -3b. Again, some of you may not need to show that step, but I'm still going to show that here. 1 plus -3 is going to get us -2b plus 8 equals 18. Like the last question, our goal is to get this into a two-step equation that we know how to solve. So at this point, the inverse of adding by 8 is to subtract 8, so we'll do that to both sides. That's going to get us -2b equals 10, and then divide both sides by -2. 10 divided by -2 is going to get us -5 for our solution. So just like the last question, simplify first, get it to a two-step equation, and solve from there. The one mistake I see students make really often on these questions is they realize that they need to subtract 8 from both sides, but then they start trying to subtract b more than once from the same side, or add b more than once to the same side. That's why I like to just get it down to a two-step equation that we know how to solve. simplify it first. Otherwise, you're more likely to make mistakes. All right, let's take a look at numbers 16 and 17. So number 16, kind of like our last question, we're going to want to simplify first. So I put my 5 and 8, my two constants, side by side. No need to add the opposite here. This gets us down into a two-step equation, which is 2p plus 13 equals negative 11. And again, I want to stress, sometimes students will put the 5 and the 8 side by side, and they'll try to subtract 5 from the 5 and subtract 5 from 8. That's twice on the same side of the equation. And remember, this is a balance, and that balance point is the equal sign. So you can't do it twice to the same side. Otherwise, you're taking two things from one side and not from the other, and that's going to leave our balance unbalanced and no longer equal. So at this point, once you get it down to a two-step equation, the inverse of subtracting by 13 is to of adding 13 is to subtract 13. Now be careful, negative 11 minus 13 is not 2 or negative 2, it's negative 24, so we get 2p equals negative 24. Divide both sides by 2, negative 24 divided by 2 is going to get us, let me slide this back up, negative 12 for our solution. Now our next question is not quite as complicated. There's no simplifying to do. However, number 17 is going to get us a decimal answer. So a lot of the problems that we've seen thus far, we've gotten whole number answers or integer answers. I want to show you that we can also get decimals or fractions. So the inverse of subtracting by 9 is to add 9 to both sides. Negative 12 plus 9 is negative 3. So we get 6c equals negative 3. Divide both sides by 6, so you're doing negative 3 divided by 6. Your calculator's probably going to get you negative 0.5 in this case. And negative 0.5 is the same as negative 1/2. So you could write it as negative 3 over 6, what we have here, negative 3 over 6, and then just simplify that to negative 1/2. But again, we can get decimals or we can get fractions for our solutions here. Let's talk a little bit about number 18 as well. So number 18, we've got 5b plus negative 12. The inverse of adding by negative 12 is to add a positive 12. Negative 15 plus 12 gets us negative 3. And then we divide both sides by 5. Since we're multiplying by 5, the inverse is to divide by 5. Now you can leave negative 3 divided by 5 just as negative 3/5. If you actually divide in your calculator, it's probably going to give you a decimal, and that decimal is negative 0.6. So either the decimal or fractional answer is acceptable. Usually if we have fractions in the problem, it's wise to leave your answer as a fraction. If you have decimals in the problem, we generally leave the answers as decimals. But for this one, we don't have fractions or decimals in the original problem. So it doesn't really matter. They're both equivalent. And they both work. And it also depends on what situation we're looking at as well. If we're applying this to a real life situation with money, decimals make more sense. If we're talking about a recipe, for example, fractions might make more sense. All right, we'll continue with these notes in just a moment.
So let's begin with numbers 19 through 24. What we're asking you to do is translate each sentence into an equation. We did this with one-step equations already. Now we're just going to do it with two-step equations. So let's read through the problems and translate them. Number 19, it says 6 more than twice a number is negative 20. Quick reminder that the word is generally is going to represent our equal sign. We've got 6 more than, so more than is going to represent one of our operations. In this case, that's going to be addition. And then when we say twice a number, I'm going to highlight this in green. Twice a number is going to represent 2 times your variable. So I'll choose a variable n here, and I'm just going to put 2n since I'm taking twice that number. So when we go to put all this together, we're going to have 6 plus 2n equals negative 20. So again, just translate it word for word. You just have to be familiar with some of these words and phrases. Number 20, we have 18 is 6 less than 4 times a number. Don't forget the word is generally represents our equal sign. So we can start by writing 18 equals. Then we've got 6 less than. Less than, of course, represents subtraction, but we need to be careful with that phrase because we need to switch the order in which those things are written around a little bit. 4 times a number is obviously going to be 4n. So I'm just going to highlight that all together and make that 4n. Now be careful again because you don't want to write 18 equals 6 minus 4n. Since it's 6 less than 4n, you want to subtract 6 away from the 4n. So 18 equals 4n minus 6. You could also write 4n minus 6 equals 18, but the 6 has to come after subtraction. The 4n is going to come before subtraction. All right, number 21, the quotient of a number and 5 increased by 8 is equal to 14. So hopefully remember that the word quotient means division. This gets really tight in here, so I'm not going to type that in. But the quotient of a number and 5, this is going to represent our unknown. Now, because of the order in which these are written, I had someone ask this the other week, how do we know what order we put these in? Well, if it says the quotient of a number and 5, the number comes first, so that's going to go on top. 5 is going to go on the bottom. The phrase increased by means addition, and then so we've got plus 8. Finally, we finish with is equal to, so our equal to symbol, and then the number 14. So n over 5 plus 8 equals 14. Number 22, 4 more than 3 times a number is negative 26. So we see this phrase more than again, like we saw back in number 19, that's addition. 3 times a number is going to represent 3n. And then, of course, we have is, that's equals negative 26. So 4 more than is 4 plus. 3 times a number is 3n. Set that equal to negative 26. So pretty standard questions. We always like to start here before we get into those more challenging word problems, but they will get more difficult here in just a few moments. Number 23. 24 is 6 less than twice the number. So 24 is, that is going to represent our equals. We have our 6 less than. Remember, though, we need to switch that order around as we write it, and then twice a number is 2n. So when we go to write this, this is going to be 24 equals, but 6 less than twice a number is taking 2n and subtracting 6 away from that. So 2n minus 6. Again, watch the order when we talk about both division and subtraction. Those are not commutative operations. The order is going to matter. Finally, number 24, the quotient of a number and 7 increased by 6 is equal to 12. So the word quotient means division, as we saw back in number 21. So the quotient of a number and 7, that means n, our variable, is going to go on top, 7 on the bottom. Increased by, again, so this looks really similar to number 21, plus 6 is equal to 12. So n divided by 7, or n over 7, plus 6 equals 12, and that's it. All right, well, we've got to kick it up a notch. We can't just see the easy word problems like that. We have to make them a little bit more real life related. Now, I do want you to recognize that the questions you're going to see here, I think the numbers are really simple. I made them simpler than they would probably be in real life. So you'll see that here with our first question. Number 25 says, Josh is saving money to buy a cell phone that costs $100. He has already saved $60 and plans to save $5 each week. A, write an equation to represent this situation, and we're going to begin by identifying what we're trying to find or are unknown in this situation, just like we did with one-step equations. B, solve your equation from part A to determine how many weeks it will take for Josh to save the money to buy the cell phone. So when I talk about being really simplified, most cell phones, especially today, are not going to cost $100. They're going to be a really weird number like $7.99, $8.99, $9.99, maybe even something like $6.99, $99. But I did want to make these numbers work out nicely and work out evenly for us, despite the fact that in real life they would be more challenging. But we might as well start with an easier version for now. So what are we trying to find in this question? Well, it's always going to tell you somewhere in the problem what you're trying to find. In fact, it says, determine how many weeks it will take for Josh to save the money to buy the cell phone. That is our unknown. So what I put in this box, even though we don't typically write this box out, we're trying to find the number of weeks it will take Josh to save $100. And that's $100 total. That includes what he already has, plus what he's going to save in terms of earning money or saving money each week. So when I defined my variable, I chose W for number of weeks. I always like to choose something that makes sense, so I typed in W equals number of weeks. While I don't need to see what's in this box, I think it is important to type out or write out W equals number of weeks. I'm going to say type out a lot because I feel like I do that so much this year. Now, let's put all of this into an equation. So we know the cell phone is going to cost a total of $100. Generally, when you're looking at a question like that, your total is going to be the thing that goes by itself on the right-hand side of your equation, like this, equals 100. We know that he's already saved $60 and he plans to save $5. Let me highlight all of that. Plans to save $5 each week. Now, keep in mind, W represents the number of weeks. So we have to figure out which number our variable is going to go with. Well, if it says $5 each week, then we know 5 and W are going to be squished together. We're going to be multiplying them, right? 5 times W. The $60 can be added on to what he's saving each week. So we can write this as 60 plus 5W equals 100, or 5W plus 60 equals 100. I have seen students write 100 minus 60 divided by 5. There's nothing wrong with this in and of itself, but you need to set it equal to a variable because it asks for an equation. And if you write this, this is technically wrong because you don't have parentheses around the 100 minus 60. You need parentheses around the 100 minus 60 because otherwise order of operations would divide before you would subtract. Sometimes people think, well, I wrote the 100 minus 60 first, but it doesn't matter in math because order of operations, division takes precedence. So be careful with this. This would be correct. You could write this, or you could write 100 minus 60 over 5, then you wouldn't need the parentheses. But if you're using the division symbol, either a slash or the division symbol itself, you really do need to have parentheses around the 100 minus 60. That's really, really, really important because otherwise it's going to be marked wrong if you don't have the parentheses, you don't have it written as an equation. Now, the easy part is the next part. That's solving the equation. So let's use our inverse operations. The inverse of adding 60 is to subtract 60. So we'll subtract 60 from both sides. That's going to get us 5W equals 40. Divide both sides by 5 to get our final solution. And again, I made it work out to be a whole number. The reality is in real life, you might get a decimal, but we get 8. Somehow I lost my label on this, but I'm going to put a label of 8 weeks on this. I do think it's important to label your final solution. So what we know is it's going to take Josh 8 weeks to save that money to buy the cell phone. And this is a good real life situation. If you're trying to budget to figure out how long until you can buy a new cell phone, or how long until you can go on that trip you want to go on once COVID is out of our way. But these are things that are good real life types of questions, and they're more complicated in real life, but we have to start with the easy problems first. All right, let's see another one like this. So number 26. It's a little outdated here as well because we're talking about CDs. So if you're like, what in the world is a CD? Well, now we don't really play CDs too much because we get our music right on our phones or from the radio. I still remember as a kid using cassette tapes to create mixtapes of different music that I enjoyed. And sometimes the stuff that was inside of those tapes would get all wrinkled up. The tape inside of there would get all wrinkled up, and you'd have to try to fix them. Ask mom and dad about those things. That's some oldies but goodies. So number 26, Jasmine bought 6 CDs all at the same price, which is unusual as well. So we're just trying to make this as easy as possible. The tax on her purchase was $7 and the total was $73. Again, in real life, tax is probably not going to be a whole number, but I want to make the numbers work out nicely for us. We're going to write an equation to represent this situation like we did in our last question, and then we're going to solve your equation from part A to determine the cost of each CD. So let's identify our unknown here. Our unknown is the cost of each CD. So I'm going to be very specific in defining C as the cost of each CD. I'm not just going to put C equals CD. That's not good enough. We want to be very specific. Now, to write an equation to represent this, we know that she's purchasing 6 CDs, and they're all the same price. Well, keep in mind that C represents the cost or price of each. We also know that the tax on her purchase was $7. So that's what's going to be added on to the 6C. And the total is the thing that's going to go by itself on the right-hand side. That's 73. So we can write 6C plus 7 equals 73. Again, pretty standard two-step equation. You're going to have a number times a variable plus something, or sometimes minus something, but a lot of times we're adding some extra number on. In this case, it happens to be the tax. All right, part B, solve your equation from part A to determine the cost of each CD. So we have 6C plus 7 equals 73. We're going to subtract 7 from both sides. That's going to get us 6C equals 66. Finish by dividing both sides by 6. And hopefully we get the correct solution here of $11. Keep in mind, it's a good idea to label your solution. I've had students write 11 CDs. In fact, I think I might have done that in the past on an answer key and had to fix it. In this case, we're trying to find the cost of each CD. Each CD is $11. Again, a very simplified version of a real life problem, but we have to start somewhere. All right, let's shift gears a little bit to numbers 27 and 28, which are a little bit more challenging. Our last two questions, I also have an independent practice problem for you to try as well to lead into the week after Thanksgiving when we see some more of this and some more complicated equations. So number 27 says, Liana bought a DVR from her cable company. She must pay a one-time fee of $80. After 1 year, the cost of the DVR will be $224. So over 1 year, that's what she's going to spend on the DVR. It's a little bit more updated in real life stuff. So letter A, write an equation that can be used to determine the monthly cost of the DVR. B, solve your equation from part A. First things first, let's identify our unknown. So our unknown in this case is the monthly cost of the DVR. So I defined a variable to represent that, and I said M equals the monthly cost of the DVR. From here, I'm going to put all this other information together. Now, I'm going to start here that the cost will be $224. That's after 1 year. That's the total cost. We also have this one-time fee of $80. That's not going to be multiplied by anything since you pay it one time and that's it. It's not dependent on how often you use it. It's not dependent on the number of months. So this is just going to be something added on. We saw this with the flat fee in a previous performance task. And we know that after 1 year, the DVR is going to cost this. And if M represents the monthly cost, there's a number that's not given in this question we need to use. Hopefully you recognize it as the number 12 because if we're talking about 1 year, I'm going to highlight this in green. That's a period of 12 months, right? So we've got to use the number 12. I'm going to put MO for months. So we can write this as 12M for 12 months times the M, the monthly cost of the DVR. Add on our 80, which is our one-time fee, and set that equal to 224. So 80 plus 12M or 12M plus 80 equals 224. Again, the 12 is the number of months in a year since M represents the monthly cost. Let's go ahead and solve this. So we're going to start by subtracting 80 from both sides. 224 minus 80 is going to get us 144. Divide both sides by 12. 144 divided by 12 is 12. So the monthly cost of the DVR is $12. All right, let's take a look at question number 28. Our last word problem before I give you one to try independently. It says the temperature is 12 degrees Fahrenheit. It is expected to fall 3 degrees each hour for the next several hours. A, if the temperature is expected to be negative 9 degrees Fahrenheit after several hours, write an equation that can be used to determine how many hours the temperature fell. B, solve your equation from part A. First things first, we are trying to determine how many hours the temperature fell. So mind me as I take a sip of my coffee. I went for a run this morning. It was a little chilly, and it's a little chilly down here in the basement, so I've got to have some coffee to warm me up. So we're trying to determine how many hours the temperature fell. That's going to be H equals number of hours. Let's go back to our information here. We know that the temperature began at 12 degrees Fahrenheit. So that's what we're starting at. And it's expected to fall 3 degrees. So falling indicates subtraction to us. And it's falling 3 degrees each hour. Keep in mind, H, we just said, represents the number of hours. And then our final, our total, right? In this case is where the temperature is going to end up being. It's expected to be negative 9 degrees Fahrenheit after several hours. So we can start off by writing 12 minus 3H, set that equal to negative 9. So you started at 12 degrees, fell 3 degrees each hour, so 3H, and we end up at negative 9 degrees Fahrenheit. Now to solve this one, don't forget, I'm going to say it many, many times. Anytime the variable comes after subtraction, please add the opposite. So we're going to get rid of this plus 12 by subtracting 12 from both sides. We get negative 3H equals negative 21. Divide both sides by negative 3. Negative 21 divided by negative 3 is going to get us 7. Our label on this is hours because we want to figure out how long it took for the temperature to fall to negative 9 degrees Fahrenheit, and that would be 7 hours. Okay, I want to finish this video because I don't want to make it too long for you, but I want to give you a word problem to try here. So go ahead and pause the video, read this question, Give it a try, and when you're ready, restart the video and we'll take a look at it. All right, so for this question, we want to start by determining what we're trying to find. And it says here, determine how many weeks it will take for Elliot to be able to buy the headphones. This is really similar to the cell phone question, although maybe a little bit more updated and a little bit more realistic. So I'm going to say W equals number of weeks. Now we know the headphones themselves cost a total of $125, so that's going to go by itself. We know that he has already saved $11 and he plans on saving $6 each week. Keep in mind, W represents the number of weeks. So our equation can be 11 plus 6W equals 125. Let's solve this. Hopefully you've already done it. If you haven't already, you might want to pause the video and solve this equation. Make sure you get the correct solution. All right, let's go ahead and subtract 11 from both sides. That's going to get us 6W equals 114. Divide both sides by 6. We will get a total of 19 weeks. So quite a bit of time to save that money, but it will be over a 19-week period. So let's take a look at number 29 to begin. In the 2004 Summer Olympics, the United States won 11 more medals than Russia. Together, they won 195 medals. A. Write an equation that can be used to determine the number of medals that Russia won. B. Solve your equation from part A. C. How many medals did the U.S. win? So this is a step above some of the previous word problems we saw. You're going to see this box here, which is not something that would typically be given on a word problem that you were asked to complete on a test or a quiz or a graded assignment. But I did include this here to kind of guide us in the right direction. It tells us to define a variable, and we define the variable R to be the number of medals that Russia won. Now, we're also going to write an expression for the number of medals that the U.S. won. So in this case, we know that the United States won 11 more medals than Russia. So if Russia won R medals, then we can represent the number of medals that the United States won as R plus 11. Now, while we could say Russia plus the United States equals 195, that's great. That's information that we know. But if we have two variables and two unknowns, it doesn't really help us find our final solution. But if we can use the same variable more than once, and we did see some questions like this earlier in the unit as well, R can represent the number of medals that Russia won. We know that the United States won 11 more, so we can represent that as R plus 11. So in part A, it asks us to write an equation that can be used to determine the number of medals that Russia won. So our equation is going to involve the variable R. And that does help us figure out how to define our variable, since it says to determine the number of medals that Russia won. That told us that we needed to do R equals the number of medals that Russia won. And we're going to use R in our equation. But we also need to use the fact that together, both countries won 195 medals. So I set this up sort of as an equation in words first, and I said Russia plus the United States equals 195. Now that's very simplistic. We're talking about the number of medals each country won, but the number of medals that Russia won plus the number of medals that the US won has to equal 195. Russia is the variable R. US we set up here was R plus 11 in this box above, so we can write R plus 11 equals 195 for our equation. Now we can also simplify that, which I'll do down here in part B, but if you want to simplify it, you could also write it as 2R plus 11 equals 195. Again, we saw problems like that when we did algebraic expressions, but we didn't actually write equations, and that was in our last unit. So we saw this last unit, and now we're building on this to write equations. Now part B asks us to solve our equation from part A. So part A is the hard part. Now we just have to solve that equation. So write R plus 11 as 2R plus 11. Subtract 11 from both sides. That will get us 2R equals 184. Finally, we'll divide both sides by 2. How many medals did Russia win? Well, we determined that Russia won 92 medals. R equals 92. 184 divided by 2 is 92. So if we want to figure out how many medals the US won, keep in mind, up here highlighted in yellow, the United States won 11 more medals than Russia. So we take 92 plus 11, which is 103 metals. You can also kind of double check your solution here and do 92 plus 103 and make sure it gives you your total of 195 metals. So again, a little bit harder than the problems we saw before with multi-step equations, but we did see this in our previous unit. We wrote expressions like this where we had the sum of two people's ages is 52, and we had to write an expression to represent the sum of their ages. So we're kind of building on this, similar to what we would have done in our previous unit. All right, let's take a look at number 30. So we aren't going to just see one question like that. We're going to see a second one, plus a third one in the form of a multiple choice question. Because I know these are tricky, and this is something we'll focus on in class as well. So number 30, it says, you and your friend spent a total of $25 for lunch. Your friend's lunch costs $3 more than your lunch. A, write an equation that can be used to determine how much you spent for lunch. B, solve your equation from part A. C, how much did each person spend on lunch? All right, so keep in mind we're trying to determine how much you spent for lunch. So I defined a variable to represent that. I chose Y to represent the amount you spent on lunch. We know that you and your friend together spent a total of $25. So I wrote this in the form of a sentence. You plus your friend equals 25. But we also know, I'm going to highlight this in green, by the way. There we go. We also know that your friend's lunch costs $3 more than your lunch. So we can represent your friend's lunch as Y plus 3. So I'm going to type this right here. We can represent how much your friend spent as Y plus 3, since your friend spent $3 more than you. So the equation I can write here is Y plus 3 equals 25. The Y is for you. The Y plus 3 is for your friend. In fact, I'll highlight that in yellow. So you is the Y. Your friend is going to be the Y plus 3. And we know that gets us a total of 25. So Y plus 3 is 25. Again, that's the tricky part. The Y plus 3 represents the sum that they spent for lunch, or the total they spent on lunch together. Set it equal to 25. Now let's solve this equation. We can write it as 2Y plus 3 equals 25. We're going to subtract 3 from both sides to get 2y equals 22. Finish by dividing both sides by 2 to get the fact that you spent $11 on lunch. Again, the solving part we move through pretty quickly because it's pretty routine. The rest of it is the part that I think is a little bit more challenging. So part C, how much did each person spend on lunch? Well, we know you spent $11. We know your friend spent $3 more than you. So you spent 11. Do 11 plus 3 to figure out how much your friend spent. That's going to get us $14. We can also check to see they totaled to 25. 11 plus 14 is indeed 25. All right, let's see another one of these. So this is a multiple choice question similar to what you might perhaps see on your test. Let's take a look at it, and feel free to try this one on your own. Number 31, Billy and Erica spent a total of $65 at the movies. Billy spent $9 more than Erica. If E represents the amount of money that Erica spent, which of the following equations represents this situation? Well, we need to keep in mind that Billy and Erica together spent a total of $65 at the movies. We also know that Billy spent $9 more than Erica, and so we can represent that as E plus 9 or 9 plus E. I typically write it as E plus 9, so let's go ahead and do that. So we've got E plus 9 for Billy. So if we have Billy plus Erica equals a total of 65, let's take a look at what we have. Erica plus Billy is 65. Erica is E. We know that Billy is E plus 9, as we set up here from this yellow highlighted statement. Simplify that to get 2e plus 9 equals 65. So we try to find an equation that matches that as we look through here. That's going to be choice D. Now it's very tempting to think that it's always going to be 2 times a variable plus the other number equals your total. It's not always going to be the case, so be careful. A lot of times it will, especially if we're dealing with 2 people, but it won't always be 2 times your variable plus the extra number in the question. But this one does match with the previous ones. All right, so 32 and 33 are actually a little bit more challenging than what you're going to see on your test, but it is a good preview of things you might see in algebra. So let's take a look at number 32. It says two consecutive integers have a sum of 111. Write and solve an equation to find the two integers. So this is going to kind of build on what we just saw, which is why I think it's good to see these questions, especially if we have the time to do so. But I need to define what consecutive integers are. So consecutive integers are integers that are 1 unit apart. For example, -4 and -3, or 5 and 6. They're 1 unit apart. Now, you could do a guess and check for this, of course, but I'm actually going to write an equation to represent this. So first off, I'm going to let x represent our first integer. So then if they're consecutive integers, then my second integer can be written as x plus 1. So the equation that I could write here, whoops, sorry, did not mean to reveal the answer. You didn't see that, or maybe you did. The equation that I can write here is that x for the first integer plus x plus 1 for the second integer can equal 111, since we know the sum, which means adding those numbers, has to equal 111. So x is the first, x plus 1 is the second. That gets us 2x plus 1 equals 111. Subtract 1 from both sides to get 2x equals 110. Divide both sides by 2, and of course x is going to be 55. So that means our first integer is 55, which tells us that our two consecutive integers are going to be 55 and 56. And we can check that. 55 plus 56 will indeed add to 111, and they're consecutive or back-to-back integers. So let's try number 33. This one says three consecutive integers have a sum of 87. Write and solve an equation to find the three integers. So x could represent the first integer, which means x plus 1 would be the second integer, and x plus 2 is the third integer, because I need to be 2 more than my original number. So my equation will be x plus 1 plus x plus 2 equals 87. We have a total of 3 x's plus 3 for our constants. 1 plus 2 is 3, equals 87. Subtract 3 from both sides to get 3x equals 84. Divide both sides by 3. My first integer is 28. So remember, we have 3 consecutive integers here. So it'll be 28, 29, and 30. And you can actually add them together to see that they total 87, and they will. So again, that's just a really quick, short version of a few more challenging word problems. We'll, of course, see some more to practice in class as well. Thanks for listening.